These are the examples for Algebra 1B, Credit 2, Lesson 17.3. Lesson 17.3, we're going to be talking about subtracting polynomials. And so question gets asked, well, how do we subtract polynomials? And kind of the short answer is we don't. Now, don't stop the video. It doesn't mean we're not going to do the work. But what it means is when we're doing a subtraction problem with polynomials, we change it to an addition problem. And so that's the first step. We're going to have an example for problems 1 and 2. We only have 4 problems here, and then an example that'll serve for problems 3 and 4. But basically, these are all very similar in how we do them. All right, so let's take a look at what we really mean by change this to an addition problem. And then once we change it to an addition problem, then the work is the same thing that we did in the previous lesson when we were adding polynomials. All right, so first step here, an example for problems 1 and 2. First thing we're going to do is, again, change it to an addition problem. And I'm going to do that, the subtraction into addition. I'm going to circle it just to emphasize that we've changed it to an addition problem that has no mathematical or calculating significance. So now what you do, see, what you might say, well, you can just change it to an addition problem and that's okay. It is, but we have to do one other thing. And that's change the signs of each term in the parentheses on the right, or the second parentheses, just this one. We don't change anything here, just here. So a positive 16 becomes a negative 10 becomes a positive 10, and a positive 25 becomes a negative 25. So positives became negative, a negative became a positive. Once we've done that, now we're just going to do what we did in the last lesson, which is group or collect our like terms and then simplify. So again, you might want to, if this is the first time you're seeing this, you might want to pause, rewind the video just to make sure you got a good understanding of what it is we did there. All right, so let's go ahead and start collecting our like terms. Remember, like terms are same variable and same exponent. So we have 10x squared plus a negative 16x squared. Notice same variable x and same exponent too. And again, we can cross those out. That might be helpful. And because that way you don't have to look at those again. You just focus on the remaining terms for collecting them. So here we have a 12x and a 10x. And you might say, well, how do we know that those have the same exponent? Well, remember that when there's no exponent written, we know it's a 1 there. So this is 12x to the first, 10x to the first. So that takes care of those. Finally, our constant terms. So we have a negative 30 plus a negative 25. Let's see if we can squeeze that in there. I think we got it. All right, so now let's go ahead and simplify each of these. And so for our first one here, we have a positive 10 and a negative 16. The signs are different, so we subtract. 16 minus 10 is 6, x squared. However, comma, as we like to say, the larger term is negative, so we have a negative 6x squared. I always say, however, comma, like as my daughter often says. All right, next are x's. This one's a little more straightforward. They're both positive, so just add them up. 12 plus 10 is 22x. And then finally, in our last pair of terms here, our constant terms, the signs are the same again, but this time instead of being both positive, they're both negative. So again, we add them up. 30 plus 25 is 55. But since they're both negative, the answer is negative. So our final answer here in our example, negative 6x squared plus 22x minus 55. All right, and again, pause and rewind that to study that a little more if you feel like that's needed. All right, so let's take a look at an example for problems 3 and 4. Once again, we're doing a subtraction, and our first step in any subtraction problem is to change it to an addition problem. So let's go ahead and do that. That is now an addition problem. And remember, we have to change the signs of each term, each of the 3 terms in this second parentheses here. So a positive 20 becomes negative. A negative 11x becomes a positive 11x. And a negative 7 becomes also a positive. All right, so now let's go ahead and group our like terms. we have an x squared here and an x squared here. So we have 15x squared plus a negative 20x squared. We can cross those out again to help us. Next, our x's, we have 13x plus 11x. And we can cross those out. And then the only thing that remains are the constant terms. We have a negative 20 plus a positive 7, or we could just say negative 20 plus 7. Now it's just a matter of combining these like terms here. So we have a positive 15 and a negative 20. So signs are different. So we subtract. 20 minus 15 is 5. So 5x squared. But the larger number, the 20, is negative. So that's a negative 5x squared. In the middle here, these are both positive. 13 plus 11 is 24. So 24x, a little bit easier when they're both positive, but it still follows the rules. Signs are the same, so you add them up, and the answer keeps the same sign. They were both positive, so positive 24. It's just that we're kind of used to adding positives, and so we just say, well, just add them up. But again, that still follows our rules for signed numbers. Lastly, for our constant terms, the signs are different this time. We have 20, negative 20, positive 7. So 20 minus 7 is 13. Remember, we subtract when the signs are different. However, the larger number is negative. So our answer is negative. And our final answer here, negative 5x squared plus 24x minus 13. All right. So that should give you everything that you need to know to do the problems there in lesson 17.3. And again, as we always say, pause and rewind to study the examples, and we'll even step out of the way for just a second in case you want to pause that there to study it more. But good luck with the work, and until the next video, take care and God bless.